Hey, how's it going, everyone? My name is Tuton. I'm over here at the University of North Carolina at Pembroke, my mentor being Dr. Barr. And my research was evidence beta-1 integrin responses are involved in seizure vulnerability that compromises hippocampal synapses. So cognitive risks of long-term space travel. There are several potential stressors and high-risk health consequences to the brain and synaptic integrity involved with long-term space travel. Some of these potential stressors include traumatic brain injury or TBI, turbulence-induced mild TBI, lack of sleep, isolation, hypoxia, all of which have been linked to increased susceptibility to seizures. Understanding the mechanisms of this synaptic integrity degeneration in seizure-related events would vastly improve our ability to preserve the cognitive health of our astronauts. So what do? We took these mature rat hippocampal explants, and we used these explants because they maintain the native organization of the brain. And so we exposed the explants to 200 micromolar of the acetylcholinesterase inhibitor peroxone, and peroxone being an acetylcholinesterase inhibitor, meaning acetylcholinesterase is the thing that cleaves acetylcholine. So if we inhibit that, we get a seizure type event. So this is how our model works. We have the hippocampal explants that maintain the native organization, and we have the insult being peroxone. So some of these slices were exposed to only 200 micromolar of peroxone. The other slices were exposed to 200 micromolar peroxone with bio 5192, and bio 5192 is just a beta-1 integrin inhibitor. So the slices were quantized either by fixing the slice for confocal imaging or harvesting the slice for Western blot. This is what a confocal image looks like. You can clearly see the hippocampus, and this is what a harvested slice would look like. In a Western blot, we get these bands here. So these are our the confocal images that we acquired. And so we can see here we have synapsin-2 and beta-1 integrin. Synapsin-2 being this green punctate marker. And synapsin-2 is just a synaptic marker we use. Because we use synaptic markers because, especially in a study like this, we need to know when synaptic decline has occurred. And so this beta-1 integrin being this red, you can hardly see it in the vehicle or the control, this red little punctate marker. And so once we insult the vehicle or the control, we get a significant decrease in synapsin-2, our synaptic marker. But interestingly, we get a significant increase in beta-1 integrin. And that relationship is demonstrated in this graph right here. So what exactly is going on? So here's our Western blot images, and we can see the same relationship we just saw. We see beta-1 integrin with the vehicle. Once we insult it with peroxone, the band goes up, meaning that there's more beta-1 integrin. And we see here the vehicle has a lot of synaptic marker. After insulting, we get a decrease in the synaptic marker. Synapsin-2, synapsin-2 and synaptophysin are both the synaptic markers we use. We use a bunch of them, but these are the primary ones we use in this sort of study. And they both demonstrated a synaptic decline after the insult. But what's interesting here is if we take a look over here, we see that the control, this is our control band, right? Nothing has been done to this specific band. And once we insult it with peroxone, we get the same relationship we have over here. There's an increase in beta-1 integrin. But once we have a peroxone and bio 5192 on the same band, we get a band that looks like the control. So what does this all mean? So the implication of the study is the therapeutic role of integrin modulation, leading to preserving synaptic integrity. However, more data is needed to understand the specific relationship between synaptotoxic events and compensatory adhesion responses. Thank you so much for listening to my talk. I hope you have an excellent rest of your day.